Hello friends, welcome back to this online lecture series on earthquake resistant design of structure. Now as you all know that we are discussing the calculation of lateral loads based on the dynamic analysis method, that is the response spectrum method, right? And in the previous lecture we have seen the calculation for the modal analysis, where with the help of modal analysis, that is based on the values of mode shapes that are given to us, we can calculate the modal mass, and after calculation of the modal mass we can calculate the modal mass participation factor, and once that is done then we can calculate the individual lateral force that is going to be considered for each of these stores, and lastly then we have to do the calculation for calculation of lateral forces for the combined modes, as well as the calculation of storey shear for the combined modes as well, right? In the previous lecture we have seen the calculation up till the third stage, where is the calculation for the lateral forces and base shear for the individual modes that we have seen using the methods that we have seen in the last lecture. In today's lecture we are going to discuss about the last two steps, that is the calculation of lateral forces and calculation of storey shear based on the combined modes, right? So when I am talking about the combined modes, then in that case the code is discussing basically two types of methods, where the first method is known as the SRSS method and the second method is CQC method. So today's example that we are going to discuss is going to be based on these two methods, that is how to calculate the values of combined storey shear and combined lateral forces based on the values of the mode shapes that we have. So let us start today's lecture, where first we will be taking up the method of CQC method, and after that we will be looking at the example of SRSS method, right? So as you can see in the figure over here, the data is given where the calculate for the lateral forces and the storey shear data shown in the figure below. Calculate the seismic forces using the SRSS and CQC method, where the value of angular frequency omega 1 is indicated as 6.33 radian per second and omega 2 equal to 17.34 radian per second, right? Now what I have done over here is that I have taken up only the part problem, because the steps that we have seen in the previous lecture up till that stage everything is going to be remain same whenever the data is given to you, where the mass is given to you, stiffness is given to you, and the mode shape values are given to you, right? So when you will be given these three data, then based on these three data you will be able to calculate the values of the modal mass participation factor, and the design lateral forces, and lastly the individual lateral forces and the storey shear based on individual modes, as we have seen in the last class up till there. From there on, the step forward is the calculation of combined modes, and in that case the method of CQC or the SRSS, whichever is mentioned, can be used to calculate the values of storey shear and the lateral forces for the combined modes, right? So what I have done is that in the last class, if you remember, then we have drawn the mode shape figures for individual mode, that is mode 1, mode 2 and mode 3 in the last problem that we saw, right? And for that all the three modes we have drawn the individual diagrams of lateral forces and the diagrams of the base shear, right? And in case of the comparison between the lateral force diagram and the base shear diagram, we have seen that the highest lateral force will be available at the roof level, and that is at the top level, and the highest value of base shear will be at the available at the base level, that is the bottom level. So that similar type of data is given, that where the modal analysis, that is the first three steps are completed, and after this diagram is available to you, from there on we are starting the problem. The data that we have taken for this problem is different than the last one, but however what I have done is that I have given the values of angular frequency, and I have given the values of lateral force and base shear individually for all the three modes as indicated in the figure over here, right? So the values are values of lateral force and base shear for mode 1, mode 2 and mode 3 are indicated in the figure over here, and the value of angular frequency are given. Now the question that comes in mind is that, as you can see that again three mode shapes are there. When three mode shapes are there, three values are there, that is giving us an idea that the actual building is going to be a G+2 building, because if you will have more than two values, then only you can have three mode shapes and correspondingly three values for each of the mode shapes. However, in the data I have mentioned the angular frequency of only first mode and the second mode. I have not mentioned for the third mode. Why? There is a reason for it, right? So that reason will be known to you when we proceed ahead in the problem, right? So this is the basic data. Omega 1 is given to you, omega 2 is given to you, and the values of lateral force and base shear for each of the individual modes, that is mode 1, mode 2 and mode 3 are given. Now once this data is available to you, or you reach this particular stage in the problem when you are doing the solution based on the SR, that is the response spectrum method, then the fourth step that comes is the calculation of storey shear based on the combined modes. And for that, one of the methods that is suggested by the IS 1893 is the CQC method. So what is the IS CQC method? The CQC method is telling that the calculation for combined modes can be done by the formula lambda is equal to under root of sigma equal to I equal to 1 to j, I equal to 1 to n, and sigma equal to j, sigma j equal to 1 to n, where lambda I into lambda j into rho ij, right? If this is the formula that is given for the CQC method, that is lambda is equal to under root of sigma equal to I equal to 1 to n, sigma j equal to 1 to n, lambda I lambda j into rho ij. Now what is I, what is j, and what is lambda I and lambda j? So rho ij is known as the cross modal coefficient, and lambda I and lambda j is the response quantity in that particular mode, that is the mode I and mode j, including the sign convention. That is, whatever the sign convention is available to us in the figure, that sign convention. If it is positive, we have to use positive values. If it is negative value, we have to use the negative value. Right? So lambda I and lambda j are the response quantities in mode I and mode j, and the rho ij is the cross modal coefficient that is going to be there. Right? Now the question comes is, we are going to have three modes, as we have discussed, that if it is going to be a 3-story building, we are going to have three modes, right? So how the modal combination can be done? Then the code is telling that you can do the combination for either of these combination of two modes if the aggregate value of the modal mass participation is greater than 90%, right? So if you look at over here, then I am taking the consideration for mode 1 and mode 2. Why? Because if I am calculating the percentage mass participation for mode 1, then the value is coming as 92.25, and if the percentage of mass participation for the second mode, then it is coming as 6.99. So this value is coming as 92.24 or 99.24, which is greater than 90%, and therefore it is sufficing with the clause, and that is why I can take up this value. Similarly, you can take for 1 and 3 also, right? Because major amount of modal mass participation is going to be in the first mode, and it is going to be less in the second mode and the third mode. So either you can take 1 and 2, and either you can take 1 and 3, but you cannot take 2 and 3 together, because in that case the value is going to be less than 90%, and if it is not less than, it is less than 90%, then in that case the code, that criteria that is mentioned in IS 1893 is not satisfied, and hence the modal combination cannot be considered for these two modes, right? So either of these two is possible, but for here this particular example, the modal combination is done for mode 1 and mode 2, and similarly I am sharing the calculation accordingly over here, right? So now the formula is there where rho ij is indicated as the cross modal coefficient. So for the cross modal coefficient, the formula is given as 8 into eta 1 plus beta into beta raised to 1.5 divided by 1 minus beta square the whole square plus 4 eta into beta 1 minus beta square 1 plus beta the whole square. So this is the formula that is given in the code also, where rho ij is I and j are again the coefficients of the mode shape values, that is mode 1 and mode 2, right? So when I am talking about cross modal coefficient, then in that case what you have to do is you have to prepare one kind of table over here, where rho ij is given, then the suffix value, that is rho 11, rho 12, rho 21 and rho 22 are mentioned, and corresponding value of I and j. So when I am having the rho value as rho 11, that means I equal to 1 and j equal to 1. When I am taking rho 12, that means I equal to 1, j equal to 2. When I am taking rho 21, that means I equal to 2, j equal to 1. And when I am taking rho 22, that means I equal to 2 and j equal to 2. Right? So this type of table you have to prepare to consider all the possible types or all the possible combinations of rho ij. And once that is done, then what you have to do is you can calculate the value of beta. Now beta is given by, beta is the ratio of omega j divided by omega I, that is the angular frequency ratio, right? So beta is equal to omega j by omega I. Now what is the value of j and I to be considered? Then value of j and I has to be considered corresponding to the value of cross modal coefficient, that is rho that you are considering. So if I am calculating the value of rho 11, then in that case I can see that the value of I equal to 1 and j equal to 1. Therefore in case of beta, the value of beta will be beta is equal to omega 1 divided by omega 1. Why? Because j is also 1, I is also 1 for the first case, that is rho 11. If I am talking for the second case, that is rho 12, then in that case beta will be equal to omega 2 by omega 1. Why? Because in case of rho 12, the value of j is 2 and the value of I is 1. So therefore the value of beta can be calculated by beta is equal to omega 2 by omega 1. Similarly for the other two cases also, right? So this thing is also important to understand. Once this thing is clear, then I can calculate the value of beta for the first case, that is rho 11 is equal to omega 1 by omega 1. Now omega 1 value I am having as 6.33. So if I substitute, I will get the value of beta equal to 1. right? And eta is nothing but the damping ratio. So for concrete structures, the code is telling that the damping ratio is to be considered as 5%. So that is why the value of eta will be equal to 0.05. So substituting the value of beta is equal to 1, eta is equal to 0.05, remaining all the values are constant. We substitute this value and we'll get the value of rho 11 as 1 in the above equation when you substitute, right? Similarly, if I want to calculate for the second case, that is rho 12 or rho 21, both the cases, again it is going to be different. So rho 12, if I substitute, then in that case I again need to calculate the value of beta. Why? Because beta is equal to omega 2 by omega 1. So omega 2 is 17.33 and omega 1 is 6.33. I substitute the value and I get the value of beta is equal to 2.74. Right? Now we have to substitute this value of beta is equal to 2.74, eta is equal to 0.05 in the equation of rho 12 and we will get the value of rho 12. So when you substitute, you will get the value of rho 12 is equal to 0.079. Similarly, I can calculate the value of rho 12 and rho 21 both separately also, but in both the cases you will get the value same because the coefficient values are remaining same. And similarly for rho 22 again the value is going to be 1. Why? Because again beta is going to be 1. And since beta is going to be 1, as we have seen in case of rho 11, the value is coming as 1. Right? So now I have all the values of rho 11, rho 12, rho 21, rho 22. That means out of the total equation components that I have, that is lambda I, lambda j and rho ij, I have the values of all the possible values of rho ij. Right? So that based on which I can work out the response quantities and based on the response quantities I can calculate the value of shear. So I need to prepare a table where the first column will be the values of mode 1, second column will be value of mode 2, then the combinations can be 1 1, 1 2 or 2 1 and 2 2, and lastly storey force and lastly the storey shear. Right? So this is the kind of table that we have to prepare. So if I look at the values of mode 1, mode 2, then these values are going to be from the table or the figure that is given to you in the first slide. That is this particular figure that is given to you. From this figure, you have to substitute these values of mode 1 and mode 2 that is shown over here. Right? So for 3, 2 and 1, for all the 3 force corresponding values of mode 1 and mode 2 are to be substituted and listed in the table shown over here. Once that is done, then the modal combination start, that is 1 1, 1 2, 2 1 or 2 2. Now how these values can be arrived or how the calculation of these values can be done, that I am going to show you in the next slide. For example, if I am showing the sample calculation for V3, now where is V3? Then in case of V3 I have shown that in the first column in the mode shape 1 or the mode 1 value I have written the value as V3, V2 and V1. So if I want to calculate the value of V3, then sample calculation I am showing over here. That is for mode 1 the value for V3 corresponding value of V corresponding value in mode 1 is the value of 947.78 kilonewton. So when I am taking 1 that means lambda will be lambda I equal to lambda 1, lambda j equal to 1 and at the same rho ij will be equal to rho 11. Right? So rho 11 value is 1 that we have obtained. Lambda 1 will be the value that is 947 and lambda 2 value will be again also lambda j value will that is again going to be lambda 1 and that is why the value is going to be 947 again. So for mode 1 the value will be 947 into 947 into 1 that is equal to 898 value to 898 287 value that you can see over here. That value is to be substituted in the first, that is the third row, third column, that is the 1 1 value. Similarly, if I want to calculate for 1 2, then in case of 1 2 what is going to happen is that lambda I will be equal to lambda 1, lambda j will be equal to lambda 2 and rho ij will be equal to rho 1 2. Right? So if I substitute these values, then I will get that the first value will be 947, second value will be 1334 and value of rho ij, that is rho 1 2 will be equal to 0.079 that we have calculated. Now in this case, as we have seen that the value of rho 1 2 and rho 2 1 is same, so that is why I have multiplied with 2 over here, and that is why when you multiply you will get this value that is showing over here. Similarly, I can do the calculation for rho 2 2. So again lambda 2 into the value of rho 2 2, that is again going to be 1. Substituting this value I will get this particular thing. Right? So once I have got these 3 values, you can see that in the first row I have got all these values of 1 1, 1 2 and 2 1. Similarly, I can calculate for the second level. Similarly, I can calculate for the third level, that is V2 and V1 also. Whatever values you are going to get, you have to substitute these values in the table that is shown over here. And once that is done, then you can calculate the value of story force using the formula that is given in the equation, original equation, that is the value of under root of, it is going to be a summation of all this, because it is sigma I equal to 1 to n and sigma j equal to 1 to n, right? So once these values are calculated, then you just have to do the algebraic summation. So that is why all these three values you have to put together and under root of it, and when you do that thing, then you will get the value as storage force as 1643.3 kilonewton or 1643.3 Newton, as you can see over here, right? So that is the value of story force that is shown. Then again from there story shear, then again same concept we have seen earlier, that from the story shear it is going to be a cumulative summation. So in the first column or the first row, the value is 1643. In the second column, it is going to be 1643 plus the second value that is shown in the story force. Similarly, for the third column, it is going to be 1643 plus the value of second column that is shown for story force and the third value that is shown for the story force. So when you substitute, you will get the final value as 4903 Newton, that is shown over here, right? So this is how the value of story force and story shear can be calculated based on the CQC method, right? So individual value is also available to you, final value is also available to you. Now one of the checks that you have to perform is that this value of base shear that you are getting should be equivalent or greater than the actual value that you have obtained from the analysis. If it is not happening, then as a result of that, the correction factor has to be applied. And in order to calculate the correction factor, or whether the correction factor is required or not, this small check has to be performed. How do we perform this check? Then what we do is that since we have considered the value of mode 1 and mode 2, we take the value, average value of AK for mode 1 and average value of mode 2 for AK. So AK is equal to the value, that average value of AK that we have obtained from mode 1 and mode 2. That is, if I substitute these values, then I will get the value as 0.09. Then the seismic weight is available to me as 8000 kg. I convert it into Newton and then I calculate the value of VB dash. So VB dash is equal to AK into W. So I substitute these values and I will get the value as 7576 Newton, which is greater than 4903 Newton, which we are getting from the table. So since the value is greater than the actual value that we have obtained from the table, that is why the correction is not required. If the correction is required, then in that case what you have to do is that whatever the difference between the two values that you have to take as a factor, as we have seen in the earlier cases in structural dynamics also, and that factor has to be applied and made sure that the value of static base shear and the dynamic base shear is almost near about, right? So that thing has to be ensured if this check is not matching. So this is how the calculation for CQC method is done. Similarly, the next option that is there for the combination of modes for availability of lateral forces and base shear is the use of SRSS method. That is sum of root of sum of square method, right? So SRSS method, the formula is lambda is equal to under root of sigma equal to I equal to 1 to n lambda I case the whole square, right? So in that case, the calculation is much simpler, where you have to calculate the value of V3, V2 and V1 using the value of individual story shear that is available to you from the figure itself. That is under root of V3 is equal to under root of V31 square plus V32 square plus V33 square. Similarly, if it is for 2, then V21 square plus V22 square plus V23 square. Similarly for 1 also. So when I substitute these values from the figures that is available to you from the first slide, then I will get the values of individual values, as you can see over here, right? So once I am substituting all these values, I will get the individual story shear that is going, story force that is going to be there. And from that, if I am going to do the reverse calculation, that is if I want to find out lateral force, then what is going to happen, that Q3 value is going to be remaining the same because it is going to be the highest value, right? So Q3 and V3 will be same. But when I talk about the second value, that is V2, then in that case it is going to be the first value is going to be minus, that is the value of 1590 has to be subtracted and the second value will be. Second, again the value of third value has to be subtracted and again you will get the value of 950. So again the value of nature of lateral forces that you will get will be similar to that of the actual figure that we have. That is, maximum lateral force will be available at the top and minimum lateral force will be at the bottom. And if you talk about base shear, then in that case what is going to happen, it is going to be reversible in nature, where base shear is going to be maximum at top, maximum at bottom and least at the top, right? So same kind of behavior can be obtained from CQC method also. So these are both the independent methods based on which you can do the modal combinations, and based on the modal combination you can calculate the value of lateral force and the value of the story shear accordingly. I hope the calculation of the response spectrum method using SRSS method and CQC method is clear to you. I hope you enjoyed today's lecture. Thank you for watching this series. Thank you.